All right, in this lesson, we're going to learn how to simplify radicals. So in order to simplify radicals, we need to know the perfect squares. And the perfect squares are these numbers right here, 1, 4, 9, 16, etc., etc. So we can continue this list on forever, right? The next one would be 13 times, or 13 squared would be 169, 14 squared, 15 squared, etc., etc. But what we should be able to do is we should be able to recognize these numbers right off the bat and know they are perfect squares. The reason we call them perfect squares is because we can get them by doing 1 squared, which equals 1, which also means that when we take the square root of any of these numbers, so for instance, the square root of 64, we get a whole number and it's just 8. All right, so here's how we simplify radicals. So in the past, this is what we've learned. We've learned, okay, when we get a square root answer, we put that in our calculator. And if we get a decimal answer, we end up just rounding. So we would leave this as square root of 32, and then our approximate answer would be approximately 5.66. But what we're going to learn how to do is how we can actually simplify the square root of 32. And in order to do that, what we need to do is first we're going to list out the factor pairs of 32, meaning the numbers that we can multiply to make 32. So I always like to start with 1. So 1 times 32 equals 32. And then I just go up from there. So 32 divided by 2. So that's 2 and 16. Let's see if 3 goes in. 32 divided by 3. No. 32 divided by 4. 4 and 8. Let's see if 5 goes in. No. 6. No. 7. No. And then we have 8 and 4, which you've already listed. So here are my factor pairs of 32. Then what we're going to do is we're going to scan our list and we're going to find the largest perfect square. So the largest perfect square that I see, so I see 2 perfect squares. I see 16 and 4, but 16 is the largest perfect square. So this is what we're going to use to rewrite the square root of 32. So we're going to rewrite the square root of 32 as the square root of 16 times the square root of, square root of 16 times 2. Since 16 times 2 is 32. And then there's a rule with radicals that we can actually split these radicals apart. So we can write this as the square root of 16 times the square root of 2. Well, if we look at our calculator, square root of 16, the reason we chose it is because it's a perfect square. Square root of 16 is 4. So this is actually going to be simplified to 4 times the square root of 2. So square root of 32 simplified is 4 times the square root of 2. All right, so let's look at another example. So 54, again, I'm going to list out my factor pairs, 1 and 54. Let's see, 2, 27, 3 and 18. 4 doesn't work. 5 doesn't work. 6 and 9. And I think that's it, but let's just see. No, 8. And then back to 9 and 6. So here's my factor pairs. So again, I'm going to scan through my list and find the largest perfect square. So 54 is not a perfect square, so it can't be this pair. Well, I should cross off this. It can't be 27. 18 is not a perfect square. 9 is a perfect square, so this is going to be my pair, how I'm going to rewrite square root of 54. So I like to write the perfect square first. Doesn't really matter, though. And then we're going to split it apart. So square root of 9 times the square root of 6. And then square root of 9 is 3. So this is going to be 3 times the square root of 6. So square root of 54 simplified is 3 times the square root of 6. All right, here's another example where while we have a number on the outside, for now we're just going to ignore that number. So I'm still going to list out my factor pairs of 72. 2 and 36. And actually, here's what I'm going to say. We can actually stop here. Since I know that 36 is a perfect square, and I know that these numbers are just going to get smaller and smaller, I know that 36 is going to be the largest perfect square. So we can actually stop here, and we know that this is going to be our factor pair that we're going to rewrite it as. All right, so the 4 is going to stay on the outside, and I'm going to rewrite this as 36 times 2, and then I'm going to split. So it's going to be 4 times the square root of 36 times the square root of 2. All right, well, 4 is just going to stay 4. Square root of 36 is 6, and then we have the square root of 2. Okay, last thing we can do, the numbers on the outside, we are allowed to multiply those. So 4 times 6 is 24. So this is going to be 24 times the square root of 2. All right, so now let's talk about multiplying radicals. So when we're multiplying radicals, you can kind of think of it as like terms. If they're both under the radical, we can multiply them. If they're both on the outside, we can multiply them. So here we have the square root of 6 times the square root of 10. So first thing I'm going to do is I'm actually going to multiply the 6 into the 10. So the same way we can split these apart, we can actually put them together. So square root of 6 times 10. 6 times 10 is 60. And then we're just going to go through our same simplifying process. So 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think that's going to be it. 8 doesn't work, 9 doesn't work, and then we have 10 and 6. Okay, so here we go. So scanning through my list, the largest perfect square is going to be 4, so it's going to be 4 and 15. So square root of 4 times 15, and then we're going to split it. Square root of 4 times square root of 15, and then the square root of 4 is 2. So simplify, this is going to be 2 times the square root of 15. All right, looking at the second example, so the two numbers on the outside, we can multiply that. 6 times negative 2 is negative 12. And then the two numbers on the inside, we can multiply. So 2 times 10 is 20. And then we're going to simplify. So factor pairs of 20, 1 and 20, 2 and 10. 3 doesn't work, 4 and 5. And then that's going to be it. So looking here, largest perfect square is going to be 4 and 5. So this is going to be negative 12 times the square root of 4 times 5. So it's going to be negative 12 times the square root of 4 times the square root of 5. Well, square root of 4 is 2, so negative 12 times 2 times the square root of 5. And again, we have two numbers on the outside that we can multiply, so that's going to be negative 24 times the square root of 5. All right. So now let's take a look at dividing radicals. So with dividing radicals, it's fairly straightforward. Kind of the same idea. If they're both underneath the radical, you can divide them. If they're both on the outside of the radical, you can divide them. But you can't divide something that is not in a radical and something that is in a radical. So the other rule of dividing radicals is you can't have a radical on the bottom. So no radicals on bottom. So you have to do this process called rationalizing the denominator. So getting rid of the radical on the bottom. So what we're going to do is we're actually going to multiply this by what I like to call a big 1. A big 1 is a number with the numerator and the denominator being the same. The reason I call this a big 1 is because square root of 5 over square root of 5 is actually just 1. But I call it a big 1 because it's not just 1, it's square root of 5 over square root of 5. So then from here, we can multiply straight across, and let's see what happens. So 3 times the square root of 5, it's just going to be 3 times the square root of 5. Because remember, we can't multiply something on the outside and something on the inside. The denominator, well, square root of 5 times square root of 5, we can multiply 5 times 5. So the denominator becomes square root of 25. But we know that 25 is a perfect square. We end up with just 5. So really what happens here when you multiply a square root by itself, it cancels out the radical. So this just becomes a 5. So then from here, we need to see if we can simplify any further. Numbers on the outside can't be simplified, and there's nothing underneath the radical. So this is actually the simplified version of this. I know it doesn't look more simplified, but again, it kind of obeys this rule that we can't have any radicals on the bottom. All right, looking at the second example here. So if you want, you could simplify before you start rationalizing. However, I usually like to just rationalize the denominator first. So my big 1 is going to be square root of 12 over square root of 12. So this becomes 6 times the square root of 12. And the denominator, 12 times 12 is 144. And the square root of 144 is just 12. All right, so then from here, I'm going to see if I can simplify. So numbers on the outside, well, 6 over 12, I could divide by 6 on top, and divide by 6 on the bottom. 6 divided by 6 is 1, so we're just left with the square root of 12 on top, and then 12 divided by 6 is 2. So I've simplified the outside, but now we can actually simplify this radical. Square root of 12, so factors of 12, 1 and 12, 2 and 6, and 3 and 4. So I'm actually going to rewrite the square root of 12 as the square root of 4 times 3. And remember, we have 2 on the bottom. So this is going to be the square root of 4 times the square root of 3 over 2. Well, the square root of 4 is just 2. So we have 2 times the square root of 3 over 2. And then the very last thing, these actually end up canceling out. 2 divided by 2 is just 1. So we end up with just the square root of 3. So this is probably the most involved problem. Not only do you have to rationalize your denominator, you can simplify the outside, you can simplify the radical, and then once you simplify the radical, you can actually simplify the outside again. You end up with just the square root of 3. All right, now I'm going to go over just some of the homework problems here. So starting with problem number 1, square root of 128, we need to simplify. So first thing we're going to do is we're going to list out our factor pairs of 128. So 1 and 128 divided by 2, 2 and 64. So again, this is one of those cases where I can actually just stop. If you see a perfect square come up, this is the largest perfect square that you're going to get because these numbers are just going to get smaller from here. So I can already write this as the square root of 64 times 2. And then we're going to split this apart as the square root of 64 times the square root of 2. And the square root of 64 is just going to be 8. So 8 times the square root of 2. All right, now let's take a look at number 8. So here's number 8. We have some numbers on the outside and some numbers on the inside. So first thing I'm going to do is I'm going to multiply the outside numbers. 3 times 5 is 15. And I'm going to multiply the inside numbers. 20 times 15 is 300. So now I'm going to see if I can simplify this radical. So I'm going to list out my factor pairs of 300, 2 and 150, 3 and 100. And actually, again, I know that 100 is a perfect square, so I can actually just stop here because I know that these numbers are just going to get smaller. So I'm going to rewrite this as 15 times the square root of 100 times 3. So 15 times the square root of 100 times the square root of 3. Square root of 100 is 10. So 15 times 10 times the square root of 3. We end up with 15 times 10 is 150 times the square root of 3. Right, last one here. So here we have dividing radicals. If you want, you can simplify the 4 and the 6. However, I just like to go ahead and rationalize the denominator first. There's lots, it doesn't really matter what you choose to do first. So on top, you can multiply the 4 and the 6. So this becomes a square root of 24 over, and remember, square root of 6 times square root of 6 is square root of 36, which is just 6. So this becomes 2 times 6. So we have square root of 24 over 12. Oops. I don't know what happened. Hold on. There we go. Okay. Over 12. And now we need to simplify the square root of 24. So factor pairs of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's going to be it. So scanning my list, there are no perfect squares on the right-hand side. However, 4 is a perfect square. So I'm going to rewrite this as a square root of 4 times 6 over 12. And the square root of 4 is 2. So this is going to become 2 times the square root of 6 over 12. And the last thing we should do is check the numbers on the outside. These are both divisible by 2. So I'm going to divide these both by 2. So we end up with 2 divided by 2 is just 1. So we end up with the square root of 6 over, and then 12 divided by 2 is 6. So remember, we can't simplify this any further because this is a radical and this isn't. So they're kind of like not like terms, so we can't divide them. So my final answer is going to be the square root of 6 over 6.